Today, we are going deep inside the modern smart factory to decode the one thing that makes it all possible, its brain. We're talking about a powerful system known as MES.
So here's what we're going to cover. First, we'll figure out what this factory brain really is. Then we'll peek inside to see how it thinks. We'll follow the birth of a computer mouse to see it all in action. After that, we'll use a super simple analogy, a map, and a luggage list to break down its key parts. And finally, we'll get into why this whole thing is such a massive game changer.
Okay, let's jump right in. Section 1. What is this brain of the factory?
So, what is MES, really? Well, you can think of it as the factory's central nervous system. It's the critical link between the big picture business plan, the stuff decided in boardrooms, and the actual hands-on work happening right now on the production line. It's what turns an order into a physical product, and it does it all in real time.
Now, it's super important not to get MES mixed up with its cousin, ERP. Think of it this way. ERP is the brain of the entire corporation. It's worried about the what, sales goals, financial planning, HR. But MES is the brain of the factory floor. It's all about the how. How do we make this thing right now, with perfect quality and full traceability? They absolutely have to talk to each other. If they don't, you get chaos, with sales promising things the factory has no idea how to deliver.
So does this mean factories were just brainless before all this tech? No way, not at all. They ran on paper, on tons of spreadsheets, and most importantly, on the incredible experience of the people working there. But all that knowledge, it was kind of informal, tribal knowledge. The real magic of MES is that it takes all that human expertise and builds it into the factory's DNA, making it systematic, repeatable, and visible to everyone. All right, so now that we know what it is, let's get to the really cool part. How does this brain actually think? Because it's not just passively watching things happen, it's actively directing the show.
So, let's ask the big question. If we're calling MES a brain, what is its fundamental thought process? What's going on in there?
The answer, the absolute heart of how MES thinks, is something called process modeling. Honestly, it's pretty simple in concept. It's about creating a perfect, step-by-step digital recipe for every single product that the factory makes. I'm talking from the very first component to the final box it ships in.
And this is how that plan becomes reality. The process model is the roadmap, the plan. But a plan is useless without action, right? That's where things like track in and track out come in. They're like digital checkpoints. Every time a product enters a new step, it's tracked in. When it leaves, it's tracked out. This ensures that the plan is being followed to the letter. Without the map, these checkpoints would be totally meaningless.
Okay, this is all a bit abstract. I get it. So to make this really concrete, let's watch it in action. We're going to follow the journey of something you probably use every day, a simple computer mouse.
Believe it or not, our mouse doesn't start as a mouse. It starts as a flat, blank circuit board. The whole manufacturing journey has 4 big stages. It starts with some high-tech processes that place all the tiny electronic components onto that board. After a couple more steps, that board becomes the fully functional electronic heart of our mouse, and it's ready for the final assembly. And this final assembly stage is where MES really shines. It's guiding a worker, or maybe a robot, through an exact sequence of steps defined in that process model we talked about. Put the circuit board in, add the top cover and the scroll wheel, run a series of automated tests, do a quick visual check, and finally put it in the box. Every single step is directed, and just as importantly, it's verified by the system. Now, for this whole beautiful process to work, the system needs 2 things, 2 absolutely essential pieces of information. The best way to think about it is like you're getting ready for a road trip. You need a map and you need a list of what to pack.
Let's break down those 2 pillars. First, you've got the process model. That's your navigation map. It tells you the exact route to take, every turn, every stop along the way. Then you have the MBOM, which stands for Manufacturing Bill of Materials. That's your luggage list. It tells you exactly what you need to pack for every stage of the journey, every screw, every microchip, every piece of plastic.
And here's the crucial part. You need both. You can't have one without the other. Without the map, the process model, the system is completely lost. It has no idea where the product is supposed to go next. And without the luggage list, the MBOM, it has no clue what parts to use. Get that wrong, and you're not just making a bad product, you could be looking at a massive, expensive product recall. It's that serious. Okay, let's bring this all home. Why does giving a factory a brain like this matter so much? How does it actually change the way we make things? So, what's the bottom line? It's huge.
First, it takes all that hidden knowledge from your most experienced workers and turns it into a system everyone can use. It gives you precise, real-time control over everything. It lets you trace every single product back to its origins, and maybe most importantly, it gives you clear, transparent data so you can stop guessing and start making truly smart decisions.
So, I'll leave you with this question to think about. As more and more factories get these digital brains, as they truly learn to think for themselves, what does that make possible? How will our world and the things in it change? It's a pretty exciting future to imagine.